Hey guys, this is another video continuation on degrees of freedom. This question here is much more elaborate than the very basic one we started with. So we're just going to continue on with how to draw out, how to analyze the individual pieces of a process flow diagram, and then see whether or not this whole system is even solvable. Okay. So this question here, it will be in the description as well, and it's basically a factory process about beans and solid beans, liquid beans, and C6H14. What's important to know here in this question is that the fact that the beans are solid or liquid will it might make you think, oh, these are separate species, but in reality they are not, and that's going to affect your balances. Like when you say minus X balances, you're going to say, oh no, wait, I only have one species, or just in two different states of matter. So that's not something you might see every time, so it's good to know. Okay, so as you can see here, I'll give you the question number in the description as well, if it's in the latest edition of your textbook, so you have a bit nicer of a diagram than what I have here. But anyway, so in this question here, okay, you have an extractor, a filter, evaporator, and then this has also, I forgot to mention, the recycle stream. Okay, so that's sort of a step up to the sort of typical mass balance that you'll start off with. Okay, so recycle stream is simply, you have some leftover here that you're simply going to reuse. It's very more efficient, more green, so it's important to know. But you need to understand that, and don't get too confused, like it's still not going to have any accumulation whatsoever. It's not going to affect anything. Okay, so after reading the question, okay, hopefully you've labeled each thing, like the M1, the M2, etc. And if you've done so properly, you should get something similar to what I have here. Okay, now it's tough to squeeze everything in here, okay, but starting from the left side, okay, by the way, we're assuming a 100 kilogram basis. Okay, that's very important for these here. We're assuming 100 kilogram basis. That's what you're supposed to assume in this problem. It's not really well said in the question, but you should. So we know that the question states that you have for every 100 kilograms of bean stuff going in, you've got 300 kilograms of C6H14. Okay, and it also tells us the ratio between the oil and the solid bean stuff. From there, we know, okay, there's going to be three products coming out of the extractor: the solid bean stuff, the oil bean stuff, and now the C6H14. Okay, you're going to filter out some of the solid bean, so that's going to be coming out here, and then so here we have also the rest being oil and the C6H14 continuing on through the process to the evaporator, and then the evaporator nicely gets rid of the C6H14 and spits out our desired product of oil, bean oil. Okay, now once this is all right down, you can either try the degree of freedom yourself, or I am going to show it right here. Now, starting off with the extractor, okay, you are going to have three unknowns. You're going to have the M2, which is on your diagram that you have properly labeled, should be here. From that, we are going to have the fraction of the M2. We don't know how much is solid. We don't know how much is liquid. So you're going to have an X2 and a Y2. Okay. Now you're also going to have, like we said, we're going to have that C6H14 coming out of there, but that's simply going to be represented as like 1 minus X2 minus Y2. So once you have those, you're going to know that you have three balances. So right now we can see that we have extractor, the extractor point, we have 0 degrees of freedom. After that, we're going to break it down to the filter. Okay. And now going into the filter and coming out, we have two exit points here. The filter is a bit more complicated because there's a huge 7 unknowns. Okay, it's got the M2 that we don't know, we're going to restate that. It's got now at this exit point here, it's got M3. At the other side, continuing the process flow, is going to be M4, which we don't know about, and we don't know the percentages, the separations of the M4, so we don't know what the Y4 is. Okay, and the Y4 here is going to be the kilogram oil of beans. And of course we got to say, okay, well, what's that left over? It's the C6H14, which is going to be represented as 1 minus Y4. But, you know, as I had said, we do not need to consider that a degree of freedom, because once we get the Y4, we can get, obviously, our C6H14. Now, in this situation, there's only 2 species that are involved in this. No, there are 3 species, my bad, involved here. So that means we have 3 balances, okay? And in the question, it was also stated a oil to hexane ratio, so that's a specification, so that also takes off 1 degree of freedom at the filter location. Now moving on to the evaporator, okay? We again have now 4 unknowns again. We've got the M4 that's coming in. We've got the M5 over here being recycled. And I have leaving the entire system is the M6, which is our kilogram of oil, okay? And we don't know the Y4 as we had done in the filter, so it's again we don't know what Y4 is. At the evaporator point, there's only 2 species that concern us here. It's the oil and a C6H14, so we subtract 2 balances, and then we are left with 2 degrees of freedom. Okay. Now that is the first 3 points of interest. The next 2 points left is the mixing point, which is over here, okay, where the 2 arrows connect. So the mixing point has 2 unknowns. That's the M1. We said there was C6H14 coming in. We don't know how much is coming in. Then there's the M5, the recycle stream. We don't know either how much is coming in there from the condenser and whatnot. So that total gives you 2 unknowns. Next after that, well, there's only 1 species that's concerned here. There's the fresh C6H14, and then there's the recycled C6H14. So that is only 1 chemical species, therefore it's only -1 balance. So you do this math and you see that we have 1 degree of freedom at the mixing point. Okay. Now next we have the overall system. Now the overall system is, you think of all these separate boxes here, just combine it into 1 mega box, and you just say, okay, what's coming in out of this mega box and what's going out of this mega box. So you've got, here's the entry point, let's say, if we were to make a huge system, it would look something like this. Okay, so you'd have 1 entry there, an exit there, and whoops, this should be a bit, yeah, this would be a bit deeper. So you've got another exit there. And you also have, of course, you have the yeah, that's it. The recycle stream part in should actually be included in this mega box. Okay, since it's not leaving, it's not going out, it's staying in there. So that leaves us for this overall system. We're going to have the M1 going in that we don't know about. We're going to have the M3 leaving at the filter location that we don't know about. We're going to have the M6 leaving the evaporator, leaving the entire system that we don't know about. And we don't know, of course, the fraction at the filter location. We don't know how much oil fraction-wise is coming out here. So in this case, there's 3 chemical species, which is, that was really stated in the question. So we know that there's -3 balances, leaving us a total of 1 degree freedom for the overall system. Okay. Now, we had said there was 1 location that was 0 DOF, so that external extractor, that is going to be our starting point for this mega problem. Okay, so that pretty much sums up a big. This is probably a tougher type of question. It's a good practice. It's something much more likely to see maybe on a test or something if Dr. Burke were to give a big one. So you should be able to, fairly quickly draw this out if it's not already drawn out for you and given the specific details. You got to be able to identify very quickly all the different components like the M2, M3, M4, M5, M6, etc., and then understand all those different fractions. Okay, and you got to make sure to understand your chemical species as well, and that will tell you how to slowly subtract the unknowns.